And yeah, we're going to start all over again because you didn't hear it anyways. So, all right, let's go ahead and do it again. Welcome, ladies and gentlemen. My name is Brian McLogan, and this is week number 51. I actually need to change my title of open live streams for 2020. And tonight I am here to answer your questions as well as talk to you about your goals. So Alexa, I do see you. Thank you so much for joining in. Jose, Gabriella, Kale, do this, Mohammed, Amala, thank you so much, guys, for joining me in tonight. I'm looking forward to answer your questions as well as talking to you about getting your goals set for this upcoming year. Because one of the things that I was thinking about when I was reviewing my goals, as well as trying to think about what are some things that I wanted to achieve this year, is I was looking back into, the way that I was thinking this year was going to work out, last December, a year ago from this year, a year ago from like around this time. And it's just so amazing that, I had no idea that this year would just be flipped on its head and would resemble nothing that we would think that the year was going to be by, right? And so it's just really kind of amazing, but I am happy to announce that there are a couple of goals that I was able to achieve that I wrote down even through all of the craziness that has been through 2021. I stuck with it, and I will kind of explain why I think some of those goals really, were able to continue on, and then also give you guys some advice as far as when you guys are looking into your goals that are going to make your goals stick, because obviously that's the whole point of just writing goals, is to really kind of help get yourself, into that path and setting the direction of where you want your year to go. And then also talk about some of my 2021 goals that I'm looking into achieving for you. And then obviously I know many of you guys are past your exam, so I do appreciate those of you guys that joined in. I will be going live for my last live stream of 2021 next Sunday. So if you guys want to join me from there, I will do, I'll have one more live stream. And that kind of brings me to my first question for my goals list my first goal was actually to do 52 live streams in a row. And I know not everybody has been joining my live streams for years, but I've been doing live streams on YouTube for over 2 years now. And it was actually not last year, but the year before, I was actually going live maybe like once or twice a week. And what I was doing is I was doing my homework for my students. But it was just kind of here or there. Like sometimes I'd pop on, sometimes it'd be at 9 o'clock. It was I had to do it really late because that's when my wife would be in bed. So I'd do them late. I'd be in the kitchen, and that's just when I did my live streams. Whenever my students had their homework to be done, I would do it, but it wasn't consistent. And then last year I did the same thing, but I wasn't it was just different homes, different documents, different quizzes and stuff. I would do live streams, but again, it wasn't consistent. And so the one thing I wanted to do for this year was hey, you know what? No matter what, 2020, I want to be consistent, and I want to do 52 live streams. And guess what, guys? I mean, hopefully, knock on wood, I got one more stream to go. I know this is actually incorrect, so I'm going to go and fix this now. But yeah, I'm almost there, guys. It really is 51. I haven't been counting correctly. There was one where I went back and audited my weeks. I did miss one. It wasn't I missed a week. It was I didn't label the weeks correctly. But I've been doing this for 52 weeks. And actually, if you guys look over here, I think you guys can see, yeah. I have 155 pages worth of math problems. So every math problem roughly, I'd probably say every page roughly has around 4 questions on it. So, we're roughly looking at, I'd probably say, yeah, roughly around 600 questions that I have solved for you guys this year. So definitely a really, really cool accomplishment. And, which kind of brings me to goal number 1 for my 2021. Let's go ahead and get this out there is I want to go again. I want to get to another, let's just do another weekly live streams. So I want to continue to weekly live streams. Okay. So, cause my goal, guys, is basically, I was kind of looking into this. I want to just keep on going. So I am not going to stop. I know there's going to be life events that are going to get in the way eventually. It's just, it's just the, rule of numbers that things are going to happen. And I'm very fortunate that this year I was able to make my stream. There were some close calls. There was some times I was late. There were some times that I had to, change plans and, do different things, but I was able to get it. So I'm very excited about that. So the other things that another one of my goals for 2020 was to launch my pre-calculus course, which if you were a part of my channel at the beginning or throughout the summer, I went ahead and did that. And it was something that I was not used to, something that I was very difficult, to kind of like get into preparing for the classroom. That was going to be all online, and then also launching my course and teaching my course, which I'm currently still doing. So it's almost like adding an extra prep. So it's been much more difficult with this current landscape, but throughout that, I still launched my course. And so definitely I'm looking into doing that as well. So I'm going to go ahead and launch my course, and I'm also looking into launching some additional courses, either in Algebra 2 or looking into calculus. And those are just some ones that I want to do a little bit more in-person teaching throughout those courses. So that is definitely going to be another course. So definitely going to launch. And actually, I want to do my course twice because I kind of want to have like two different groups going through those courses. And then I think the other metric that I really want to hit, and again, it's kind of funny because I really do not care about any of this, but this is my one thing that, it's I've been on YouTube since 2010. And I think it's just, it's time that I've never really cared about what my subscriber count has been. It's never been something that drives me. Subscribers don't pay the bills. They don't do anything like that. But, I think it is one of those worthy goals. And I think one of the worthy goals about the subscribers, since I've really kind of looked into that or followed a little bit more, it's really tried to train me just to be a better content creator. And I think that 1 million subscribers, that just kind of gives me that push to like make better content and make better content that people want to watch, that people want to share. And so yeah, that is, that's not something that I achieve because it's, something I want to earn or something I want to deserve or I want to brag about. But it's really something that I want to push for because it's going to, I think, put me into, majority of my videos, I have over 11,000 videos on my channel of really just, no editing, so a lot of them have horrible audio, bad thumbnails, bad math explanations. It's all out there, right? But I really think this idea of like striving for this goal to get to 1 million subscribers is really just going to push me to be able to make better content. And one thing I've noticed is, I only upload like once a week this year. That's partly been to COVID, and then also trying to, work on some making a little bit different type of content this year. And yeah, so I think this year is one of my things is the 1 million subscribers is really a way for me to kind of quantify all the things I'm going to do. And that's as far as like editing and thumbnails and just kind of creating much more, much better content and views for that. So let's see, I had launched my course. And then another one, it was just kind of another thing I wanted to do, which was in 2021, was to grow my memberships. And that was definitely something that I continued to be able to do as far as on the YouTube memberships. And that's another thing that I'm not going to add as a goal. I'm going to keep with these three. I think that to continue the weekly live streams, launch, and get to 1 million subscribers. Because, really a lot of the things that I'm going to do to get to 1 million subscribers and to launch my course is really going to be built off of a lot of things I want to do, which is increasing my memberships, but I'll just kind of do some smaller goals, increasing my memberships on my website to over 100, or to YouTube over 100. I would like to obviously build my audience on Instagram, on TikTok, and obviously on YouTube, of course. And, just continue making better content for each and one of you guys. And yeah, so I guess another goal that I finished for 2021 was also I was taking some online courses myself. And it was very difficult. I said, hey, I need to finish these. And thankfully I was able to do that. So this year has been difficult. It's been teaching inside of this, not only teaching in this pandemic, but also, I've taught, I think, I've mentioned with you guys the first 3 months, I guess, I was teaching 4 preps with no planning period, and it was just a craziness. And then we were doing hybrid learning. I mean, I literally look back and I'm like, how was I even doing that? That was just crazy talk, and kind of stuff like that. So let's go ahead and talk about your goals because, we survived at least through that. And so I want to kind of tell you guys at least some kind of things that I would recommend for your goals. So in the description, if you guys go and look at the description of this video, there is a there's a link on my community post. And if you have not already posted your goals there, I would highly recommend that you go ahead and join the community on my community post and just post a goal. It doesn't have to be anything, personal. It doesn't have to be anything large, stretch goal, but just kind of put some. Just put something out in the out there in the open for you to go ahead and achieve. And I think it's really, really cool, really, really great to go back when you write down your goals. Obviously, that sets things in motion. And it's also really nice to, a lot of times you forget about your goals. You forget about, especially even if you write them down, you forget, where was my yellow pad? Where did I write my goals down? Some people have them posted in front, and that's awesome. But like a year's a long time. And obviously we could spend a whole live stream talking about goal setting and how to write your goals and what to write down. But I think to keep this live stream fairly basic, and at least the goal setting fairly basic for you, is just write it down and put it down in the community post. Because you know what? Next year, we are going to come back, because I'll be going live every week, so you know that. And what we'll do is next year, we'll go back through these, and I will go back and respond, and we'll kind of see if you went ahead and met your goals. So that's kind of a game, and we're going to kind of play that, and then I will let you guys know. We'll come back to this live stream as well, and we'll see if I met my goals. And I think that's going to be something very cool and very fun for those of you that are following along with my channel. So, all right, Flying Hero. Your mom, Smolvin, Adam, how are you? Alexa, Addie, yes, Utters, geez, oh man, you guys, why can't we always keep a live stream? Just civil, guys. Karen, good to see you. DM, thank you very much. Lou, my goal is give my parents live a better life. Hey, there's a lot of great goals. I've read a couple of you guys that have put new goals into the community post, and I think it's awesome that what a lot of you guys are achieving for, and I think you guys have a lot of your sights set high, and I think that is awesome to go ahead and get your year started for 2021 just with this mindset of what it is you want to accomplish. And even if your goal is not the best goal, or even if you're not sure if this is the right goal, or if maybe it's too stretch of a goal, or it's not setting the standard high enough, or if it's not specific, and like all these ways that people critique each and everybody's goals, which again, I understand, and there's, certain times and places for everything, but I think the main thing is like, don't hold those back from you just inserting your goal and putting them into that community post and put it down in writing, and, get yourself in motion to, achieving something that you want to achieve, because for a majority of you have your time now where you've taken a break from your exams. And now you really get to have that time and sit down and think, and decide what you want this next year to really look like. And if last year was any consideration, we don't really know what this next year is going to unfold, right? But I think it was pretty cool to go and see, some of the goals that I still set, and no matter what happened this year, I was still able to achieve them. And of course, there was other goals, I wasn't achieved for obvious reasons. But there was definitely, I think it's cool that no matter what happened, I was still able to kind of move forward. And that's the kind of purpose of that goal setting for you guys. So, all right, let's go ahead and get on to some questions. Where did I see? No, I do not know the Math Sorcerer. I am aware, Alexa, of the Math Sorcerer's, his videos, but I am not aware, do not know him personally. All right, so once you guys have got your goals down in the community post, just a reminder, you guys can also go to Discord, and one of my goals is, I said Instagram, my TikTok, but also my Discord server. I really, really want to continue growing that Discord server. There's definitely been some updates on there, so if you haven't been around there in a while, please go ahead and take a look at that. We have some tutor roles. You also have different opportunities to be able to get roles for whatever classes you're taking. So therefore everything doesn't feel like it's overwhelming for you. So yeah, I think there's definitely some benefits for those of you guys that want to, kind of get a little bit more of an organized structure on the Discord server. That is available. So I'm looking into growing that community as well. All right. So now let's go ahead and get into some math questions. So the first one is there a constant solve a quadratic equation square root method? So this student didn't give me any examples or their name. So I'll just kind of go through a basic example. So if I had 0 equals, I don't know, x squared. Here, let's do this. Let's do 2 x squared minus 4. And then let's do 0 equals x minus 1 squared. Let's just do, I don't know, minus 5. Okay. All right, so the square root method basically is just another way for us to say the inverse operations, okay? Because when we have more than one variable for x, like an x squared and an x, you either have to use factoring or you're gonna have to use the quadratic formula. But remember, for a quadratic, you know, fundamental theorem of algebra, we're looking for two solutions. So we can use the inverse operation if we only have one x, and you can see here's one x and here's one x. So in this case, remember when you're using your inverse operations, do the reverse order of operations. Actually, let me change this to a red. And also a reminder, guys, I do have 2 spots where I will be kind of taking a break inside of this live stream and whatever questions you guys do have. Also, if you do have questions for me and you did not pre-submit your questions, these have all been pre-submitted on the Google form, which is also available in Discord. If I don't get to your question, then please feel free to go to the Discord server and you can go ahead and post it there. I'll also answer questions. But I will take 2 kind of breaks, and if there's any questions that I can maybe solve at that time, I'll be happy to do it. So I just want to let you guys know there's always people that join on these live streams and then are always asking questions like, how do I post my answers or my questions? There's multiple opportunities, you know, Google Forms prior to the stream, during the live stream, as well as on the Discord server. All right, there we go, Gabrielle. Hopefully I just answered your question, hopefully from there. So let me know. All right, so gonna add a 4 to both sides. Then 2x squared. All right, and then go ahead and divide by 2. 2 equals a x squared, and then take the square root. X equals plus or minus the square root of 2. Okay, so there you go. We have our 2 solutions, and we're good to go. Just remember, when you introduce a square root, you're going to use that plus or minus. The next question is asking us, not that. All right, so the next question, we're going to do the same thing. But again, we can't undo the 1. Like, which one are you going to do? Well, you have to undo the 5 first because that's outside of the squaring, outside of the parentheses. So the 5 equals a x minus 1 quantity squared. And then we're going to undo the square root. So therefore, that's going to be plus or minus the square root of 5 equals x minus 1. And then you can add the 1. So therefore, x equals 1 plus or minus the square root of 5. And of course, you know, you could have numbers that you could take the square root of, like 4 or 9, and then that'd make that a little bit easier. But for this one, I'm just going to go from there. Question number 2 is saying, identify 4 angles, 2 positive with 2 with positive measures and 2 with negative measures that are coterminal with 2 pi over 7. So we don't really know what 2 pi over 7. You know, we might not like what... you should know that if you could graph this angle, like if here is 7 pi over 7, then 2 pi over 7 is going to be somewhere right there, right? So again, like, we don't know like the exact measure, like in terms of degrees, but again, it doesn't really matter. You don't need to. Remember, coterminal angles are angles that have the same initial and terminal side. So I could go all the way around a circle, which would be 2 pi, and then add pi over 7, right? Or I could also go in the negative direction. I could go all the way over here and get to 2 pi. So when you're trying to find coterminal angles, all you simply need to do is add and subtract 2 pi. Now again, what is 2 pi in terms of sevens, right? Well, if this is 7 pi over 7, then 2 pi is going to equal 14 pi over 7. Agreed? So all we're simply going to do here is I'm just going to take a 2 pi over 7, and I'm going to add a 14 pi over 7. That gives me a 16 pi over 7. So I'm just going to write that down here. And then can we do that again? Of course, right? We can add another 2 pi to that. 2 pi, I'm sorry, not 2 pi, 14 pi over 7. So then you can add a 14 pi over 7. And you could keep on doing this. That's why it says 2, right? So therefore, that gives you a 30 pi over 7. right? And then we could also subtract, guys. So you could also do 2 pi over 7 minus a 14 pi over 7. And when you do that, you're going to get a negative 12 pi over 7. And then you could subtract it again. So again, adding or subtracting, that's, again, all you're trying to find is the angles that have the same initial and terminal side. So just add and subtract 2 pi, or 360 if you're in degree mode. So this would be a negative 26 pi over 7. Okay, question number 3 says, use algebra to solve each equation over the domain. Give the roots to the nearest degree. And the student was asking also like identify or simplify. Obviously, yeah, for these, you're going to want to simplify. And like verify is basically like showing one side is equal to another side. The student had a couple other questions I asked. But in this case, you know, when we want to solve, just like kind of what we did up here, we want to have, like, right here we have more than one x, right? So we can't like use the factoring in this case, but we can simplify this. So if you look at this, if I take the cosine of x times, remember, tangent is sine of x over cosine of x, what we recognize is those simplify, and we're just left with the sine of x equals 1/2. Now, based on the unit circle, it's basically saying the sine of what angle is equal to 1/2 when that angle is between 0 and 360. So you can think about the unit circle and say, all right, between 0 and 360, what angles for x produce a solution that's equal to 1/2, or when the y coordinate is equal to 1/2? And hopefully you recognize it's going to be that angle and that angle. So therefore, I'll use a solution set here, and I'll say that angle is going to be pi over 6 and 5 pi over 6. All right, the next one is cosine squared of x times secant. Well, again, remember, secant is 1 over x, right? So this is a cosine squared of x times a 1 over cosine of x. And then here, you could rationalize the denominator. So that's going to be a negative square root of 2 over 2. Now, the cosine squared over cosine, so that's going to divide out. So really, we're just trying to find the cosine of x is equal to a negative square root of 2 over 2. And again, that is for angles of x that is between 0 and 360. So what we are going to look for is, when is cosine going to be negative? Well, cosine, remember, represents the x-coordinate. So it's only going to be negative here and here, right? Which is in the second and the third quadrant. And hopefully you recognize these two angles are going to be 3 pi over 4 and 5 pi over 4. So that is the idea of knowing the unit circle. Okay. All right, let's continue on. The next one says, is there a specific problem you'd like for me to explain? Of course, I don't know why I keep reading this. So the student was asking about how many triangles, and talking about the ambiguous case. But the problem with the example they gave me is that's not the ambiguous case. Because if you were to label, like let's call this label C, A and B, right? So if this is 33 degrees, well then A would be 24 and B would be 27. Well, the ambiguous case is going to be angle side side. All right, so this is not the ambiguous case. So there's only one angle, one triangle here. So make sure that you one triangle, right? Because this is side angle side. That is not the ambiguous case. The ambiguous case is going to be side side angle, right? So what we need to do is let's assume that they maybe had a, I don't know, let's assume that they wrote this down wrong, and maybe this is supposed to be C. So let's pretend this was C equals, because they assuming they want me to answer their question. And let's call this C. Okay, so now let's go ahead and draw the triangle, same triangle. So that's 30 degrees, that's C. Actually, you know what, let's call this A right here. So that's gonna be a 24, and then C is 27. Okay, so now you can see this is side, angle, side, side, right? Angle, side, side, haha, it says a bad word, or side, side, angle, whatever. Now, in this case, and again, guys, the A, B, and C, it doesn't really matter how they relate to each other. You can move them around. But the main thing is to identify if this is an ambiguous case or not. What you're simply going to want to do is find the height. Okay, so here's the height. Now the height is going to equal, this is opposite over hypotenuse. So that's going to be the 24 times the sine of 33 degrees, right? Because it's opposite over hypotenuse. And if you did the trigonometric function, that'd be the sine of 33 degrees equals h over 24, multiply the 24 on both sides. So thankfully I have my calculator with me, degrees. All right, so it's going to be 24 times the sine of 33. Okay. Now that angle, or this side length, is equal to 13.07. So if the opposite side of your angle was less than 13, well, like let's say it was 5, right? If it's less than that, then obviously no triangle exists, right? Because it's not going to work. Like no triangle would exist. If this number is larger than 13, but smaller than 24, then what it's going to do is it's going to produce two triangles, right? Because therefore it could either be this triangle or it could be that triangle right there. So if it's larger than the height, but less than this side, then it works. You can see obviously 27 is larger than 24. So therefore there's only going to be one triangle, and it can't work that way, but it'd be one big triangle, which would be from out there. So in this example, there's only one case, one triangle. So this would be one triangle, at least the way that I did it. So hopefully that makes a little bit of sense. I had to adjust your problem, and I'm not sure if that was the right way you wanted. All right. Okay. So what's hidden? Everybody thinks about answer that. Okay. All right. So now we're into an open session for you guys. So J-Ree, KFC, how are you guys doing? J-Dog, we'll see. Nice to drop you in. Steve Castro, thank you so much for joining in. Blaze, I copy your question in YouTube chat. Not sure what your question was, but again, guys, if you do have a question, I can maybe handle a quick one. Nothing crazy, guys. But if you do have anything that you'd like me to cover, then I will be more than happy to do it. But otherwise, I just like to say hello to you and take a little break from doing some math. I like doing these little open streams. And also another thing I forgot to mention, as maybe some of you guys are coming in, is that a couple of things I'm also going to be changing for my live streams. So as we begin into 2021, I am going to do a little bit different format for these live streams. So you guys will kind of see how that is going to change. So I definitely want to give you guys a little bit of heads up. That's definitely something that we will be kind of doing around that. All right. Jeez. So college algebra, sure. I mean, if you guys have anything that you like, have a quiz on imaginary numbers, well, good luck, KFC. Good for you, kind of imaginary numbers. Just remember, I think, if you have that I through I to the fourth, hopefully that will be doing you good. So I'm just here to say thank you for helping me on your exam. Well, you are very welcome, Popville. Glad I could help you out. What is the difference between radians, degrees, and a calculator? Also, I hope you're doing great. Thank you so much. I can answer the radians and degrees problem. Thank you very much. That's a good one. So let's talk about that. So again, I mean, the basic idea, guys, is if you're looking at, degrees, okay, and let's think about this as a circle. Oops. Okay, that's supposed to be a circle. Top. Okay. But yeah, all the way around a circle is going to be 360 degrees, right? That is the rotation all the way around a circle. And then you could say halfway around is going to be 180, right? So those are our two very popular measurements that we use. And then all we want to do as far as smaller measurements of degrees, all we simply do then is just like break them down into, into further units, right? Dividing them by, 2s, 3s, and whatever else to get like 1 degree, right? Which is 360 of units all the way around a circle. Well, when we're looking at a radian, what we're looking for a radian is going to be, it's not just some random like broken down version of 360. What a radian simply is going to be a radius, or the radius of a circle. Let's wrap this. Another horrible circle. But yeah, all a radian now is going to be the radius wrapped around the circle, right? And what we found is there's 1, 2, 3 radians, and then halfway around a circle is pi. So therefore, all the way around a circle is 2 pi. Okay? So when we're dealing with measures of radians, we're dealing them with in terms of basically the radius wrapped around the circle, which we call a radian. And again, that's just it's another way to represent the same type of angles that you have. But in this case, we're going to be dealing with in terms of pi, and the degrees is just going to be kind of like this arbitrary unit system that we've broken up a circle into 360 separate units. So it's very important that when you are using a calculator that you are in the correct mode for degrees and radians. And because your calculator will, I believe it's all defaulted, or it depends on the calculator, it's going to be defaulted using the radian form, which I think is a little bit easier to understand. But a lot of us are more familiar with degrees. So as we start getting into trig, I start working with my students, helping them learn the radian mode and understanding radians better than degrees, because it is, I think, in my opinion, much more useful, much more easier to apply and understand. Do you have any colleagues who majored in pure math? I do not have any colleagues that majored in pure math, but I do wish I could go back and do some more pure math. All right, so let's get back into it, guys. I only have, I believe, 4 more questions, and then if you guys do have another open question, you can ask that then, as well as also remember, you guys can go to the Discord and go ahead and post any questions there. All right, so this next one was saying, Anaya is a member of the swim school team. The average number of swim laps. Use the line of best fit. So, I think that's kind of an understanding. I'm not going to go through the statistical line of best fit, but just kind of understanding that, like, if you're going by like tens, right, 20, right, and then you're going to get to 90. Now, here we have all these data points, okay? So, you could use the line of best fit. You could actually calculate a line of best fit. But I just want to kind of like, as I look at these answer choices, there's a couple things that I, recognize here is that we don't really need to do a calculation. Because hopefully you guys can see that it's rather obvious that this graph is increasing, right? As I'm going to go to 100 laps, which would be the next set, like it's probably going to be somewhere right on there. It's a good estimation, right? And without really even using any units, you could see like, well, what number then would make the most amount of sense? If already at 90, at 90 minutes, I'm at 148 laps, well then once I get to 100, it's going to be more than 148. And the only option they have for me is here, which is 160. So, how long it take you and I to swim 100 laps? Oh, that was going to be, I didn't read the question. Yeah, so sorry about that. That's 100, that's going backwards, right? That's why you got to read the question. So this one is saying how much would it be for 100 laps? So that means 100 laps is roughly going to be somewhere around here. Right? That's going to be between that. So it's not that answer. Geez, read the question. But I would definitely say 59 minutes. That's probably the most missed question, right? People not reading it correctly. But if you think about it, it's 100 is right there, right? So it's roughly going to be right around 58. Okay. And again, you could create a line of best fit, from there. But looking at this, I'm not seeing any data points that are all crazy. So I would just go off of the 148 without actually creating a line or doing any statistical analysis from there. All right. The next one is Nishadi Week is asking something about piecewise functions. So I got kind of confused on this one because that's an S, I believe. Okay. And that is where the question was coming in from, is I think just really B and C. Or not B and C, but really C. Like how is f of 0.1 and f of 1, how are you getting your values of 1? So it's really important to understand, well, what does this graph even look like? So you got to remember, like, let's plot this graph real quick. So it's equal to from -1 to 1. Okay. The graph is equal to 1. All right. So that's going to be equal to 1. So here, let's say 1 right here. So 1 and then 2, 1, but that's an open circle. And then from 0, what the heck? Negative 1 to 1, 0. Oh, it's equal to 0. Sorry. From 1 to 2. So 1 to 2. So that's going to be close. Okay, so it's going to be from there, from 1 to 2. And then s minus 3, so that's going to be a -of -3. So, and that's going to have a slope from 2 to 3. So that's up 1 over 1, up 1 over 1, up 1 over 1. So that'd be from there. So 1, 2, 3. So up 1 over 1, up 1 over 1. Okay, so then from 2, so that's going to be an open circle and then close. All right, and that's going to be 2 to 3. All right, fine. I'll do this semi-correctly. It doesn't really, for the student, the question the student was asking, don't really need to go through all this. All right, but anyways, that's hopefully I'm pretty close with my graphing form of this. Now the student was asking, like, why is f of 0.01, 0.05 equal to 1? And why is f of 1 equal to 1? Well, again, like, look at the, is it f of 1? f1 is not equal to 1. f of 1 is equal to 0. Yeah, that's not equal to 1. So let's kind of go through these points. Okay, so first of all, f of 0.0, I deleted the message, so I'm not really sure what the real question was. F of 0.05, right? Basically, there's two ways to answer this question. One is look at the restrictions. So this restriction is like, where does 0.05 fall within? If it doesn't fall within a restriction, right, you could say it's undefined. Like, you know, where is f of -2? F of -2 is not in the domain, right? So f of -2, you could say does not exist. It's not in the domain of this function. And like, think about, like, look at -2. There's nothing there, right? There's no output value at -2. So f of -2 does not exist. But what about f of 0.05? And if you go to 0.05, which is between 0 and 1, you can see it's like right there. So what is this y value? Well, that y value is obviously 1, right? Because that's obviously a graph. And you can see, doesn't 0.5 go between -1 and 1? So when you're trying to evaluate your function, you can look at the graph, and hopefully that gives you a visual understanding. But the way that I was looking at this is, you know, look at your restrictions of your piecewise function. And since 0.05, 0.05, not 0.5, 0.05. But either way, it doesn't matter. Since 0.05 falls within restriction of -1 to 1, you're going to plug it in for this function. Well, you can't really plug 0.05 into that function, but you can see that y value is equal to 1. So therefore, that's going to be the value. Now, when you're looking at 1, you have two options, right? So you have this first one, let's just underline them. You have this first function where is for all values that are less than 1, and then this function, which is for all values for s, which is greater than or equal to 1. Well, here 1 is included, and here 1 is not included. So therefore, f of 1 in this case is going to equal a 0. And there you go. That is how you would evaluate that piecewise function for them. All right. Question number 8. Is there... Oh, Louisa was asking something about mixed numbers and dividing fractions. I don't know, and that's why I like to have like pictures or an example. So yes, I don't know how to solve dividing mixed numbers over fractions. So I'm not really sure what Louisa is asking. So I am just going to go through one example. Let's just do 7/4 divided by, I don't know, 3/4. Okay, now let's pretend that this is written as a mixed number because I want you guys to understand that in the numerator, this could also be rewritten as 1 3/4. Divided by 3/4. Okay. Now we got to be careful, but I want you to understand. I don't want you to like to be, oh, we divide these out, right? Because in my opinion, not looking at any tricks because it's been a while since I taught this. What I would do is I would stick with the writing, if you have a mixed number, is rewriting them as an improper fraction. And I think that is a foolproof way to make sure that you're doing something correctly, is when you have a problem like this, is to rewrite the mixed number as an improper fraction, take the denominator, multiply it by the whole, right, and add the numerator. Because again, like, you know, 4 divides into 7 one time with a remainder of 3. Okay. Now, remember dividing fractions. We have too many fractions here. If we want to get rid of this fraction, I multiply by the reciprocal. But again, you just can't multiply a fraction by the reciprocal, right? So you have whatever you do in the bottom, you have to do in the top. Well, again, what is a fraction times its reciprocal? Well, that's equal to 1. So we're left with 7 over 4 times 4 over 3 over, well, what's this equal? 1. Well, again, do we really need to divide by 1? No. Now, again, when you're multiplying fractions, you multiply straight across. So 7 times 4 is 28, and 4 times 3 is 12. Now, 12 does not evenly divide into 28, but I can simplify this. So let's go and see, how could we simplify that? So you could do 2. No, you could do 4, right? 4 goes into 28. Let's see, that's going to be 7 times, and 4 goes in 3 times. Right, so that'd be a 7/3, which you could also rewrite into a 3 divides into 7 2 times with a remainder of 1. So there you go. There's a fraction. Hopefully that was beneficial. All right, question number 9. A line passes through the point 6, -2 and has a slope of -4/3. Write an equation in point slope form. So I get the student was asking something about simplifying. I'm not really sure. Typically, you know, like in a calculus class, if you just need to, or, you know, whatever the description, if the description is just saying, you know, write the equation, then just write the equation. Once you plug it into the point slope form, you're done. But if it says like write the equation and simplify, then yeah, you got to pay attention to that and simplify the equation. So here's our m, and then this is our point xy. Okay, so point slope form. And again, you could represent this as x1, y1. So point slope form, we can rewrite as y minus y1 equals m times x minus x1. All right, and from here, we're just going to plug in everything. So let's actually do it over here. So y minus -2 equals a -4/3 times x minus 6. Okay, so do a little distributive property. That's y plus 2. Let's see, that's a -4/3 x. And then if I could put this as 1, right, and multiply across. So -4 times -6 is going to be a positive 24 over 3, right? And obviously 3 goes in 24 8 times. You can subtract the 2. So you get y equals a -4/3 x plus 8 minus 2. And y equals plus 6. Okay, so obviously, guys, like that's good, right? But that's going to be good too. So, you know, that's your slope-intercept form where you can easily identify the slope and the y-intercept, and this would be your point slope form. So both are helpful equations for writing the line. And whew, there you go, ladies and gentlemen. That is it. Much more of a shorter live stream, which is pretty cool, but still took me an hour, which is just kind of crazy. All right, but if you guys do have any more questions, I do have one more open spot, so make sure that question is nice and easy and quick for me, and I'll be more than happy to see if I can answer it for you guys. But I see you, JJ, Arf Pop, Kaylin, KFC, Neeson, me as online mode. I can imagine, God, teaching online. Made me pass my exam. Well, awesome, Julio. Good for you. And Ron said, Algebra 1, 9th grade. Go ahead and get it. That's good for you. All right. 52 out of my midterm. Keep on working. Got A. Awesome. How do you add vectors? I mean, add vectors just like you're going to, you know, I mean, just when you're just add vectors, just like you add your components. So you add the horizontal components and then you add the vertical components from there. How do you graph a complex number 3 plus 2i? All you simply need to do is just complete the imaginary unit axis, which has just been a while. So I'm not going to cover the problem just because I want my explanation to be like pretty good. But yeah, you just be able to use the imaginary unit axis for on there. So you have your real number axis, and then you just have your imaginary unit or imaginary axis to add on from there. What did I eat today? I had some ham today, some mashed potatoes, and I had some pork. Actually, I had a lot of meat today. We did. I just got to think about that. But yeah, I had a whole bunch of stuff today. Can you tell me more M behavior rational functions? Sure. Well, you know, let's actually just kind of think about that. Let's just say N behavior. Okay. LCM, I mean, yeah, I mean, if you're looking at a rational function, right, that's basically like I'll touch base on the LCM and end behavior rational function. Okay. And I would definitely say, yes, I recommend Khan Academy. I think Khan Academy is a great tool. I don't really use it in my classroom this year just because it doesn't follow the way that I like to teach a lot of my classes. But I've used it in the past, and I think that the idea of being able to watch and then practice on your own is awesome. All right. These questions for kids? Yes, or adults, or whoever is learning. Again, these are all pre-submitted questions that I did for this live stream. But if you want to submit your questions, you can obviously submit them in the Google form, which is in the description. You can also go to my Discord server, which is in the description of this live stream. And then always during the live streams, I always kind of take some breaks and answer some questions for you guys as well. So that's just another opportunity for you. All right, so let's talk about end behavior. And so when you're looking at a rational function, you basically have your two options. Okay. You're basically either going to be approaching here a asymptote when y is equal to 0. Okay. And again, that is when the degree of the numerator is going to be less than the degree in the numerator of the denominator. You can also have a horizontal asymptote that is at some value, right? So you could look at something like this. Let's say, I don't know, look something like that. And that is when the degree is going to be of the numerator is equal to degree in the denominator, okay? Now, again, actually, then you could also have some end behavior that is approaching a line, and that could happen when there's a hole or you have a horizontal asymptote. So, but again, this end behavior is either going to be going to infinity or negative infinity, and again, that will depend on if it's a asymptote or oblique asymptote, or if you have a hole and you have like a line or something like that. But that is going to be when the degree of the numerator is going to be greater than degree in the denominator. So if you know your horizontal asymptote, you know, as the end behavior of a rational function is going to be approaching that, basically the end behavior from the horizontal asymptote. So it's either going to be approaching 0 if the degree is in the numerator is less than the degree in the denominator. And again, this is for polynomial rational expressions. Like this does kind of adjust and change a little bit once we start getting to other functions. So right now I'm dealing with rational functions of polynomials over polynomials. In terms of this function, this is going to be approaching the line when the degrees are the same. And then obviously this one's going to be approaching infinity or negative infinity, and that could also be reflected from there. And just real quick, actually, no, let's just do 11. I'm not going to answer any more questions because it is late and I have a lot of stuff to do. Tomorrow, I got to start recording for my, one of my goals is creating the online class, which I'm like, hey, all right, I'm going to do an online class. Like, this is so cool. And then this whole year like took off and it's like, oh my God, there's so much more work after school. And then guess what? I'm also I have to record all these videos for my online course because I have live instruction plus recorded instruction. And oh man, that's a lot. So LCM of rational functions. Okay. So just remember, if I had 1 over 3 plus 1 over 4, okay? If you're going to add these two fractions, you got to get the LCM. The LCM of 3 and 4 is going to be 12, right? So I'll multiply by 4 over 4, 3 over 3. Like 3 and 4 have nothing in common, right? So you need to multiply to get them the same, which is 7/12. That's the same thing. If this is 1 over x plus 4 plus 1 over x plus 3, right? They have nothing in common, these two. You could say, oh, they have an x, but x, that when I'm talking about they have nothing in common, I mean they don't have a factor that's in common. So you're going to, again, do the same thing. Do the same operation here. So multiply here by x plus 3 over x plus 3. Here by x plus 4. Here by x plus 4. Okay, and what you get is a 2x plus 7 over x plus 3 plus x plus 4. Now, let's continue. Let's do another one. Well, what if I said x over 3 That doesn't look like that. What if I said 1 over 3 plus 1 over 6? Well, again, you could multiply them, right? You could say the LCM is going to be 12, and let me actually write that in there. LCM is x plus 4 times x plus 3, right? But again, like you realize, no, that's not the least common multiple. The least common multiple here is 6, right? You can see that these share the number 6, right? Or that's the smallest number that they both share. So in this case, all I need to do is multiply here by 2 over 2. Then I get 2 over 6 plus 1 over 6, right? They both share a common factor of 3. So therefore, that's 3 over 6, which equals 1/2. And you say, okay, well, how does that work? Well, what about polynomials? Like, when do they have things in common? Now, obviously, when you do more advanced problems, what you're going to want to do is if you have something that needs to be factored is to factor it out. And what you're doing is you're looking for common factors. So I'm just going to do one that is kind of similar here. Like, you could multiply these together, like x times x cubed is, x times x squared is x cubed, but the LCM is not that. The LCM here is x squared. They both share a common factor of x. See, here they don't share a common factor of x. X does not divide into x plus 3 evenly, right? But x divides into x and x divides into x squared evenly. So that is why it's the LCM. You don't want to use x cubed here. Anyways, you get x over x squared plus 1 over x squared, which is x plus 1 all over x squared. All right. So there you go, ladies and gentlemen. For you on that. You Michael Jordan math teachers. No, I'm not. But there you go, ladies and gentlemen. That is it for this live stream. Thank you so much for joining in. I will be live again next week to answer your questions. So go ahead and please submit your questions into the chat, which is in the description below. I hope you guys have a restful break as well as a holiday season for those of you. And I look forward to seeing you guys next week. All right, guys. Cheers. Have a good night.